Hello, my name is Andres Medina. I'm going to be giving this presentation with Raphael Salva. This is our ME165 project, the interchangeable stovetop. So first, I'd like to introduce this topic by giving some background information on why we chose the design that we did. First of all, this is because in home cooking or cooking in general, when there's large gatherings, say for holidays, events, simple pots and pans will not cut it. This is why some chefs need a larger surface area to cook a lot of things at the same time. For example, we came up with a design that goes straight on top of a pre-existing stove top, and it's a flat griddle. So there's a lot of griddles out there. Traditional griddles do lack some functionality. This is around the normal spectrum that they come in. As you could see above in the figures, the top left figure shows that there's a raised edges all around. Same here with a handle. And there's also a grease trap in the front section of the griddle. There is opportunities for a redesign in this section in particular, as well as in the handles, and possibly even the material that's chosen for the thermal conduction. So some of our project specifications and what we came up with were this. So as you could see in the top first figure, we have this large gripped handle, and this handle in theory is to make transportation a lot easier. And if there's still heat from previous cooking, the material would be non-conductive. Uh, Also, one of the best parts about this design is the larger grease trap. This grease disposal makes it easier to dispose of any waste or solid particulates that are on top of the grill. Going off of the grease drawer, you can see that it simply inserts into this slot. Once it backs up into the slot, a back plate will prevent it from going any further. And the main idea of this grease drawer is so that, again, if there's large particulates or a lot of food waste, simply take out the drawer and throw it away in the trash, wash it, clean it, and put it back. Other notable measurements in this design were the 3-inch tall height. This makes it a lot easier on the whole material weight. As you can see, the mass is about 50 pounds, reasonable for one person to hold by themselves, although maybe easier to carry it with two people. The lengthwise, the length is about 42 inches, and the top-down length is about 25 inches, and the condension layer thickness is about 3/16. So overall, this is a lightweight product, which improves on some of the other griddles out there. Going off of an ANSYS analysis, um, starting with the von Mises stresses and the total um, forces and pressures, there's about 60 newtons force on this member here, which is the grease trap zone. So support, this force on the grease trap is applied directly normal to the surface. And as you can see, the maximum stress is about uh, 7 times 8 to 7.8 to the fifth pascals. Moreover, going off of these stresses, looking at the behind the grease trap, there's a supports here, and supports are substantial in preventing the deformation of the grease trap. Looking at the deformation again, that's 60 Newton force on the surface of the grease trap, and looking at the total deformation, it's a very minimal deformation of a 3.7 to the negative e to the 7 meters. And based off of this design, we believe that it improves on previous griddles. And from now, I'm going to pass it on to Raphael to talk about the rest of the project.
Our improvements to the stovetop grill does not just apply to what we are cooking on, rather, what system was already effective the way it was. Our motion study is based on the traditional spring knobs for igniting the stove. Before that, the reason why we are replacing the knobs is due to the electrical knob's ignition method. When the knob is turned, the system continues to light, and when liquids or spills enter, eventually the burners will no longer ignite. In comparison, traditional gas knobs would use a push-in switch that not only serves as a controlled way to allow ignition, it becomes less likely to accidentally turn on the stove, and it will provide a feel of an outdoor grill. Our design was inspired by William Holmes' ignition knob design. So the material we chose is standard stainless steel. On SolidWorks, we used AISI 316 stainless steel sheet for material. The overall assembly of the knob would be about 116.06 grams, which is around 0.26 pounds. The assembly is made up of a stopper, spring, and knob. Along the rod connected to the knob, there is a slot so that the stopper will not rotate and will consistently press the ignition switch. We plan to make most of the system be used with an average 2-pound force. Therefore, we calculated the spring constant since our max force is estimated to be 2 pounds and an expected displacement to be 15 millimeters, which results in a spring constant around 1.8 Newton per millimeter. After we looked at standard springs that could be bought, we came across a stainless steel spring on MW components which had a constant of 2.98 Newton per millimeter and found that its dimensions were around what we needed. It also has a max load of 5.7 pound force. Calculating the factor of safety, we find that it is 2.35. Our application does not really need a strong spring, so the spring being of a lower spring constant will not cause any significant damage. When doing the motion analysis, we used the spring constant found before, 2.98 newtons per millimeter, and made it undergo a 9 newton force down along the rod. Our results were off. The displacement found was well over 25 millimeters and does not seem to be making an appropriate motion study. The displacement differences range from 2 up to 129 millimeter displacement, which does not make sense. So, our improvements that we would need to be further researched would be a more in-depth analysis on how the traditional knob design would interact with the ignition switch. The current design looks bulky from simulation, and the overall length of the assembly becomes around 65 millimeters. The stopper design could include a way to flush with the ignition switch. The heads of the knobs could also be made to have a max displacement of about 5 millimeters to leave room to allow ignition. In terms of the flat top, we could design it to be easy to set up and to put away, make it a space saver. The traditional burners could be better distanced as well, as to avoid warpage on the flatbed. Also, altering the beams from the original design of the gas stove and perform FEA on that to compare the flat top would be much more educational. This CAD model was altered from a grab CAD by Farnaz. Thank you for listening.